Right now, there's a battle raging for the future of technology, and it's being fought on a scale so small you can't even see it. We're talking about this semiconductor, the tiny brain inside, well, everything. Countries are pouring hundreds of billions of dollars into this fight, but as we're about to see, winning is a lot more complicated than just spending money. So let's dive into the hidden traps of this high-stakes race. To get a handle on this, the United States has put an incredible amount of money on the table. The CHIPS and Science Act comes with a staggering price tag of $278 billion. And look, this isn't just a simple subsidy, it's one of the biggest bets on industrial policy in modern American history, all to bring the world's most critical manufacturing back home.
And that really gets to the heart of the issue, right? It feels like if you just throw enough money at a problem, it should go away. But the global chip race isn't a simple spending contest. No way. It's more like a maze, full of hidden dependencies, surprising bottlenecks, and even fundamental physics problems that money, on its own, just can't fix.
So why the huge push all of a sudden? Well, it really comes down to fixing a major weakness. The pandemic showed everybody just how fragile our global supply chains are. And with geopolitical tensions on the rise, the thought of depending on other countries for the absolute building blocks of your economy, well, that started to look pretty risky. And this slide, wow, this really tells the story. This data from the Peterson Institute shows a brutal 40-year decline. Back in 1990, the US was making more than a third of the world's chips. Fast forward to 2020, and that number had just fallen off a cliff to only 12%. That collapse is exactly why we're seeing this massive bet today. And look, the goals here are huge. We're talking about bringing the most advanced chip making back to America, locking down economic and national security, and hitting a really specific target, producing a fifth of the world's most cutting-edge chips by the end of the decade. Sounds like a solid plan, right? But reality, it's never that simple. I mean, it seems so straightforward. You just build new factories, we call them fabs, and the problem goes away. But this is exactly where we stumble into the first hidden trap. And believe me, it's not where you'd expect. You know, all the headlines are about the race for the fastest, most powerful chips for things like AI and supercomputers. But the real, immediate threat, the one that could literally grind industries to a halt, it's actually coming from their older, less glamorous cousins, legacy chips. These are the boring workhorse chips that are in absolutely everything, from your car to your coffee maker. And this is where things get really weird. Check out this paradox. A recent US government report found that chips made in China account for a tiny, almost insignificant 1.3% of the total value in American products. But then look at that second bar. An estimated 66%, two-thirds of products contain at least one of these chips. So they're worth almost nothing, but they're in almost everything. This chart just drives that point home. See all that red and pink? That's the share of products where companies are pretty sure, or at least have a hunch, that there are chips from China inside. And you see it everywhere, even in defense supply chains. You can't just decide to rip them out tomorrow, because they are woven into everything.
But here's the kicker. The problem is almost impossible to manage because most companies can't even see it. That same government report found that almost half of the companies they asked had no idea if their own products used these chips. The supply chain is just so tangled and murky that the risk is basically invisible.
Okay, so the obvious solution is, fine, if we need these old chips so badly, let's just build factories and make them ourselves, right? Well, that's where we hit the next wall, the second hidden trap. Turns out, you can't build a factory if you can't even get the tools. So here's the deal. To make old chips, you need old machines. And that, right there, is the new bottleneck. The very equipment we need to make the majority of the chips the world runs on is getting incredibly hard to find.
And this isn't just a theory. A Congressional Research Service report laid it out in black and white. The equipment is simply no longer readily available. And it makes sense, right? Companies aren't building shiny new machines to make old tech. The only way it's profitable is if you're using old, fully paid-off equipment.
So where is all this essential gear? It's scattered around the globe, sitting in warehouses or being sold on a resale market that's a total Wild West. Fragmented, opaque. We're talking about six-figure deals for critical machinery happening offline, with very few guarantees. It's basically a scavenger hunt for critical infrastructure in a marketplace that runs on whispers and handshakes. All right, so the legacy chip situation is a huge mess. We get it. But what about the main event, the advanced next-gen chips that the CHIPS Act is all about? Surely we have our act together on that front. Well, unfortunately, this is where we find the deepest, most fundamental crack in the entire foundation. Believe it or not, a basic testing principle, the gold standard for over a century, is now failing us. We're building chips that are so advanced, so complex, that our most fundamental methods for making sure they actually work are breaking down. We're talking at the level of basic physics here. For more than 100 years, engineers have depended on something called the Kelvin measurement. It's this clever four-wire trick from the 1860s that lets you measure electrical resistance perfectly. And for over a century, it just worked. Every time. Until now. The problem is that today's chips aren't flat anymore. They're like tiny skyscrapers with different chiplets stacked on top of each other. And this new 3D world breaks all four of the old test's basic assumptions. 1. Resistance isn't just in the chip, it's in the thousands of tiny connections between the chips. 2. Just touching the chip with a test probe can change the reading. And 3 and 4. The resistance isn't some fixed number anymore. It changes constantly with heat and stress. The test is measuring a world that just doesn't exist anymore. And this isn't just a science problem. It's a huge money problem. By 2030, a single high-end AI chip package could cost $25,000. Now imagine you assemble the whole thing, and then you find a bad connection in the final test. Poof. The entire $25,000 package is now a very expensive paperweight. So the solution is a totally new way of thinking. They're calling it Kelvin everywhere. Instead of one big, scary test at the very end, it's about embedding tiny sensors and constantly monitoring the chip's health at every single step of the manufacturing process. It's about tracking how things change over time, not just taking one snapshot. So when you step back and look at all these pieces together, you start to see what the real semiconductor race is all about. It's not some simple sprint to see who can build the most factories the fastest. No, it's a war being fought on 4 different fronts at the same time. You've got the geopolitical race, the one everyone sees, with all the money in the factories. But underneath that, there's a hidden supply chain race for old chips, a logistical scavenger hunt for the machines to make them, and a flat-out physics race to invent brand new ways to make sure our most advanced tech even works. So winning this thing isn't just about writing the biggest check. It's about playing a game of 4D chess. It means mastering geopolitics, supply chains, logistics, and even fundamental physics all at once. And you really have to ask yourself, is the world truly ready to play that game?